Okay, now we're going to talk about mechanical waves, what they mean, and types of mechanical waves. A mechanical wave is pretty much a wave that moves through an object that you can see, like a material object, like solid, liquid, or gas. So you can actually, I don't know, you get to, it's through physical substances, and the speed depends on properties of the medium, like elastic properties or inertial properties. There are many different types of mechanical waves, but the two most basic and common ones that we're going to talk about in this video is a longitudinal wave and a transverse wave. The first type of wave, a longitudinal wave, is a wave that the particles within the wave oscillate, and to oscillate means to move back and forth. So they may look like they're overlapping when you actually see like a diagram or something, but they're actually just moving back and forth and back and forth, and that's the motion of the wave. A type of longitudinal wave would be a P wave, and that's a wave you would see, a P wave or a primary wave, and that's a wave you would see in an earthquake. And these are fast waves. The properties of these waves, they compress. They're so fast that, like, at a seismic station where they locate earthquakes, it's the first wave to arrive, and it can move through solid rocks and fluids, so it can move through water and through the earth really fast. The next basic type of wave is a transverse wave, and this is a wave that the particle displacement is perpendicular to the wave propagation. So if a wave is going left and right, it's going up and down. And the waves are going up and down rather than from side to side. And one kind of transverse wave is an S wave or a secondary wave. And these waves are also present in earthquakes. They're a lot slower than P waves, so I guess a transverse wave would be slower than a longitudinal wave, like the movement. It's the second wave that you would feel in an earthquake, maybe like an aftershock or something. It can only move through rock and not liquid, so that's the difference between the P wave, which can also move through liquid as well as a solid. This is what led, a fun fact would be that it's what led geologists to realize that the Earth has an outer core that is liquid, because it moves up and down or side to side that's perpendicular to the direction of the wave. So through using that information, they were able to determine that the outer core was liquid, because an S wave, a transverse wave such as an S wave, cannot move through a liquid.